So the quiz is going to include the graphs from 6.4 and 6.5, which is sine, cosine, tangent, secant, and cosecant. So as a refresher for sine and cosine, we start by identifying the A. A is what's in front of the trig function. Then we find the amplitude, and that's the absolute value of A. So if A is positive or negative, obviously that positive or negative affects the A value, but we do the absolute value to get the amplitude. Then what's next to the sine or cosine would be the bx, and it could be plus or minus c. The b is what leads us to the period. We find the b, and then the period is 2 pi over b. So I would say step 1 is the A that leads us to the amplitude. Step 2 is the B that leads us to the period. Step 3 is take that period and multiply it. So the period, the first one is 0. The second one gets times a fourth, times a half, times 3/4. And the last key point is the period itself. So these are your key points. Step 4 would be to look for a phase shift. And a phase shift comes from adding and subtracting something inside the parentheses. I would set whatever bx plus or minus c equals 0, and that's going to be my phase shift. And then we add or subtract the phase shift from all the key points. And this causes your horizontal shift. Then we label the key points. God bless you. Mark the amplitude. So a positive A and a negative A on the y-axis. The key points go on the x-axis. Six would be to actually draw your curve. And for sine, it starts at 0, goes up, down, down, up. That's the shape it takes, kind of like a sideways S. And cosine starts at the amplitude, goes down, down, up, up. And then the last thing you want to do is look for a reflection, which would flip it upside down. Good morning. How are you? Okay, reflection, upside down, and a vertical shift. Up or down. And that is when you add something outside of the parentheses. So that adding or subtracting can come after it, or it could come before it. Both of those would be a vertical shift. So it could be there, or it could be there. Questions on sine or cosine? All right, then we got into 6.5, which was tangent, secant, and cosecant. Secant and cosecant start with sine and cosine. So for secant, we would graph cosine. And for, I don't know why I put two S's there. For cosecant, we would graph sine. So we do the same thing we just did. We go through all the steps except for the very last one, actually, except for the vertical shift one. We find the amplitude, we find the period, we find the key points, we plot our curve. And then let's say our sine curve looks like this, 2, 3, 4, 5. Say it went here, here, whatever that shape is. For all of the questions on the quiz, it's going to ask for 2 periods of this. So we're going to extend it. If it doesn't have a phase shift, the easiest thing to do is just reflect those points over to the left, because they would be the same points reflected. And then continue your curve that way. So it would look like that. And that would be 2 full periods, which is what the quiz is going to ask for. And then for cosecant, so this is what we're graphing right now, everywhere there's a 0, you would plot an asymptote. Yep. The period is 1 cycle, so that's 1 period. And then everywhere there's a maximum point, we're going to bounce a parabola off of it pointing up. Everywhere there's a minimum point, you're going to bounce the parabola off of it pointing down. So this would be our cosecant curve. For secant, we would plot cosine. So it would start at the amplitude. It would come down, down, up, up. We'd reflect the points. It would go down, down, up, up. Everywhere there's a 0, I would plot my asymptotes. And then every max is going to have a parabola pointing up. Every min is going to have a parabola pointing down. So if you graph your 2 full periods on the cosecant, you'll end up actually with 4 curves. And on the secant, you'll end up with 3, which is the minimum. You have to have 3. 4 asymptotes, 3 curves. We did say that if there was a reflection, like if I want to flip it upside down, I do that before I find the asymptotes. But if there is a vertical shift, you want to find your asymptotes before you shift it. So for example, if I had cosecant x plus 1, I would have found my key points. I would have reflected them. Plot my amplitude. And this is sine first. So I would have started at 0, gone up, down, down, up. Worked back the other way. And then before I shift this up, I'm going to locate my asymptotes because they are easiest to identify before you shift it because that's where it's 0. If I shift it first, they are no longer at 0. Now I would take all these points and shift them up 1. And plot my curve. Take this, shift it up 1. Plot the curve. Take this, shift it up 1. Plot the curve. Take this and shift it up 1. And plot the curve. So my sine curve would now be up here. And those parabolas would get shifted again after you find your asymptotes. Questions on secant or cosecant? Then came tangent. So remember, tangent's process is completely different. We would get y equals a tan bx minus c, and it could have d, which would be the vertical shift. A is still what's attached to the front of the trig function. It has to be multiplied by it. So A determines, there's no longer amplitude on these. A determines how high and low you plot the quarter point. So we plot this on the y-axis still. So 1, find A. 2, find B. And then get the period from there, which is pi over b instead of 2 pi over b. That's different. Then take what's next to your tangent. So you're going to take the bx minus c, set it equal to negative pi over 2, and set it equal to positive pi over 2. And those are going to be your middle two asymptotes. So you're going to solve for x. And those are the middle two asymptotes as you look from left to right. From the one on the left, you're going to subtract the period. To the one on the right, you're going to add the period. And then those will be your first and last asymptotes. And we're going to plot those asymptotes. There will be 4 of them. We're going to find the midpoint, find the zeros or x-intercepts, which are going to be halfway between the asymptotes. You're going to mark positive and negative A on the y-axis. Yep. Yeah. And they don't necessarily, like, these are reflected. They don't necessarily have to be that way. Wherever you find them to be, there could be 3 positive, 1 negative. They could all be negative. They could all be positive. Just depends on what you find from the previous step. Okay, then we're going to just eyeball. This does not have to be perfect. The quarter points and the 3/4 points. So 1/4 the way in from one asymptote to the other, and 3/4 the way in from one asymptote to the other. We're going to mark it on the x-axis. So about here and here and here and here and here and here. If it's positive tangent, then at the quarter point, we go to -a. And at the 3/4 point, we go to +a. And then we just connect those 3 points. If it was negative tangent, we would flip that. It would go up and then down. And if there was a vertical shift, you move it up or down. So if after I did all that stuff, I would then take my curve and I would shift it up if it said +1 or +2, and I would shift it down if it said minus. All right, I'm gonna ask you just to pause for a second. I'm gonna go over that first one. So most of you started good, right? So the A is 3 because it's what's in front of the trig function. And it's already positive, so that's the same as your amplitude. Your amplitude would also be 3. The B is what's attached to that x, which is 1 this time, and 2 pi over 1 would be 2 pi, so that's the period. That's your standard period for any sine and cosine function. So what I would say is if you can learn the quarter, half, 3/4 points based on that, it's probably going to help you out, which starts at 0. 2 pi times a quarter would be pi over 2. 2 pi times a half would be pi. 2 pi times 3/4 would be 3 pi over 2. And then the last one is 2 pi. And those would be your initial key points. Then because there's a phase shift this time, and I know there's a phase shift because there's something inside the parentheses added or subtracted to that x, I would say x minus pi equals 0, which means the phase shift is a positive pi. So to each of those points, I have to add pi. I'd get pi. This would be 2 pi over 2. So this is 3 pi over 2. This is 2 pi. This is 2 pi over 2 again. 5 pi over 2. And this is 3 pi. So the first coordinate point on the x-axis is pi. So if I plot pi, and then I plot 3 pi over 2, and then I plot 2 pi, and then I plot 5 pi over 2, and then I plot 3 pi, those are my key points. My amplitude is 3. There is a vertical shift down 2, but I'm going to wait to do that. So on the key points, this was sine. Sine starts at 0 on the first key point. Goes up to up to the amplitude. Down to 0, the negative amplitude, back up to 0. So my initial sine curve looks like that. This time I have to duplicate it back the other way. This is not at the 0. So in order to find those actual points, I have to figure out what's the spacing here? So I went from 1 pi to 3 over 2 pi, which is a half pi, which means my increments need to go that direction. So a half pi actually puts me back like a pi over 2 would be the next true spacing. Then it would be 0, which means if I had planned it out ahead of time, I would have worked on my vertical axis a little bit better and give myself that space. But then that means the next key point would be 0. The next key point would be negative pi over 2. The next key point would be negative pi. They share the middle one, so you only need to find 4 more. And then that sine curve does the same thing. Starts at 0, goes up, down, down, up. Now there's the second cycle of pi. So that, of sine. That's 2 full cycles, which is what your quiz is going to ask for. And then because it is a shift down 2, I am taking every single coordinate point and shifting it down 2 places. And then there's my new curve. And that would be your final answer. Jalen. Because, why did I start at pi? Is that what you mean? Yeah. Because of the phase shift. So this phase shift shifts everything to the right pi. So instead of starting at 0, you're starting at 0. Well, instead of starting at 0, 0, you're starting at pi 0. All right, we're here. We're going to do the second one. All right, so this one is secant, which means I'm going to graph cosine. So I'm going to graph 2 cosine 2x. My A is 2, which is my amplitude. The B is 2, which means the period is 2 pi over 2, and this time that's pi. There is no phase shift, and there's no vertical shift, so I don't have to shift it up either. To find the key points, I'm going to take the period. I start at 0. I take that period, multiply it times a fourth, times a half, times 3/4. And the last one is the period. So this is pi over 4, pi over 2, 3 pi over 4, and pi. Those are my 5 key points. And then because it's cosine initially, I start at the amplitude. So I'd start at 2, go down, down, up, up, make my curve. There's no phase shift this time, so it's easy to reflect those points to get the other period. I just go on the other side and do negative. So negative pi over 4, negative pi over 2, negative pi, 3 pi over 4, and negative pi. And cosine goes the same direction. At the amplitude, down, down, up, up. So there's my full 2 periods of cosine. Everywhere there's an x, I'm going to draw an asymptote. I'm sorry, everywhere x is 0. I mean, y is 0. I'm going to draw an asymptote. And then everywhere there's a peak or a max, I'm going to draw a parabola pointing up. Everywhere there's a min, I'm going to draw a parabola pointing down. So the only thing, if you had graphed this on a graphing utility, the only thing you would see are those 3 curves. All right, I'm going to do that third one. So this is cosecant, which means we're graphing sine. So it would be 2 sine x plus pi over 2. So my A is 2, which is, oh, did I make this negative on yours? Yes. Yeah, it's negative, right? Because we hadn't done the end. Okay, negative 2. Then the amplitude is 2. What's that negative tell you? It's reflected, so it's going to be upside down at the end. All right, our B is 1 because that's what's attached to the x. So the period is 2 pi over b, which is 2 pi. If we've remembered them already, that means we know our key points: 0, pi over 2, pi, 3 pi over 2, 2 pi. If you don't remember them, then you get them by doing 0, a fourth, a half, 3/4, and the period. Our phase shift, if I set this equal to 0, is a negative pi over 2, which means all of these points are going to shift left. So the first one is always your phase shift because 0 plus or minus it is going to keep it. Pi over 2 minus pi over 2 is 0. 2 pi over 2 minus pi over 2 is pi over 2. 3 pi over 2 minus pi over 2 is 2 pi over 2, which would be pi. And then this becomes 4 pi over 2 minus pi over 2, which is 3 pi over 2. So when I plot these, I'd get negative pi over 2, 0, pi over 2, pi, 3 pi over 2. My initial curve would start at, because it's sine, 0. It would go down to negative 2 because it's up, because it's negative. It would come up to 0, up to positive 2, and down. So this is my initial 1 period of sine reflected because of the negative on the front. Now I've got to find the other point. So in between each of these is again a half pi. So if I go backwards, it's negative pi, negative 3 pi over 2, negative 2 pi, and it would be negative 5 pi over 2. And this would go up, down, down, up. And that would be if it was sine. Because it's cosecant, everywhere there's an x-intercept, I'm going to draw my asymptotes. And then I'm going to bounce my parabolas off the tops and the bottoms. Okay, this last one is tangent, so we do these a little different. A is still what's on the front there, so that's still 3. B is 1. This time the period is pi over b, so the period is just pi. Then instead of doing the 1/4, 1/2, and 3/4, we take what's next to that tangent, and we set it equal to negative pi over 2 and positive pi over 2. And solve for x. So I'm going to add 2 pi. Should be equals there. X would equal, this becomes 4 pi over 2, so this is 3 pi over 2. And then on the right, add the 2 pi, or 4 pi over 2, and I get 5 pi over 2. From the one on the left, we're going to subtract the period. On the right, add the period. This becomes pi over 2, and this is 7 pi over 2. And those 4 equations represent your asymptotes. So I go to the graph, pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2, and draw your asymptotes. You want to locate the point halfway between each of these asymptotes. So here, which would be halfway between 1/2 pi and 1.5 pi would be pi. Here, 2 pi. Here, 3 pi. I want to mark the A, which is 3, on the y-axis. And a quarter the way in, because this is a positive tangent, a quarter the way in, we're going to go to the negative A. 3/4 the way in, positive A. Those points, you're eyeballing that quarter and 3/4 point. And then you're going to connect those 3. If it was a negative tangent, we'd flip it the other direction, upside down. And if there was a vertical shift here, we would take everything and shift it up or down at the end.